Hey, what's up everybody? Welcome back to another layer by layer tutorial. In today's tutorial, I want to take a look at how I built this parametric LED strip component for my latest project here. So this is what the final project looks like if you guys are interested in persistence of vision projects using DotStar LED strips. Check out this project. I'll have it linked below. Really cool way to kind of get into persistence of vision stuff, especially with microcontrollers like an Adafruit Feather, and this one's actually powered by Circuit Python. So check out the learning guide if you're interested in that. But in today's tutorial, I want to show you guys how I put together this parametric LED strip. So the main thing about this project, it's really needed a way to house this LED strip. It is a flexible PCB, and there is 144 LEDs per meter, and that's how these strips are sold. If you look at the product page here, for these DotStar LED strips, there are 144 per LED. There is some interesting tidbits here, text specs. We got the width of the strip and the pixel pitch, which is the distance between the LEDs. They're actually a little bit different than what I thought they were originally. So we'll kind of take a look at that, use these numbers, punch them in, and make a parametric model. So let's take a look at the component. This is a component that I designed outside of this master assembly, and it looks like this. It's just the strip with the LEDs spread across the strip here. So the cool thing about this, it is driven parametrically with user parameters. This is a user parameter window. And I have some useful things here, but the most useful things is the pixel count, which I call pixels. So right here you see I have 32, and you'll notice that there's no unit of measurement. That's very important for this specific user parameter. It does not have units, just a number. So I'm going to change this to 16, hit enter, and keep your eye on the strip. And right away, the strip updates. The length of the strip is updated along with the LEDs in the little circle kind of feature. So this is really cool. Another cool thing about it is I have pitch. So we were talking about pitch. How this the distance between the LEDs. Now these strips come in different flavors. They're actually low density strips, high density strips, which is the one I was showing you and the one I used in this project. So if we look at the low density DotStar strip, you can see that the LEDs are further apart, and that is the pitch. So in the text specs, you can see this pitch is actually 33.3 millimeters. So we can punch that in like that. Probably get rid of that space in the beginning, hit enter, and there is our custom design strip. Let's say we wanted only 8 pixels. Very, very cool way to quickly make a component for your project, especially for this one. Really haven't had a project where I needed to model the LED strip. This one is actually, the stick here that holds the strip is driven with this in mind. So if I actually update this right here, it'll actually tell me to update the component, and this will drive that. So let's try that out. Let me change the pitch here back to 7, right? Now I only have 8 LEDs. I'm going to hit save and say testing params. Now it's going to save, and if we look at my data panel, go to the parts where I have this saved, you'll see that it's updating. I got to wait for it to save to the cloud before I update my component here. Now you'll see I have a warning in my master assembly. It's saying, hey, you need to update this. You'll see it there and there. Notably, it's easy to change here, and it gives you a tool drop down that says, hey, there's a tooltip. It says one component is out of date. Click here. I'm going to click that and watch what happens. Fusion is going to computate all of the things, and you see that I have a little nub now. That's funny. So this stick is driven from a projected sketch from this component, so it's fairly easy to update this. So it's pretty cool. I tested it out. It tends to work now. So I'm going to increase this back to 32 pixels. Basically, kind of revert this, but not really, since I'm saving it as a new version. Updating params, and then of course wait for it to update here in the data panel. That little thing will let you know, hey, I'm saving. You don't want to update this before this isn't saved. So it doesn't take that long. So now it's saved. I'm going to click on that thing again, and it should update my model. And it takes a little bit because it's got to compute all the things. There we go. Very, very cool. So what I'm going to do in this tutorial is, now that I've showed you how it works and sort of why you would probably want to do something like this, Updating state. I'm going to show you guys how I kind of made it. So let's remake it. We're going to make a new design, and I'm going to start off with a sketch. We're going to draw on this floor plane here so we can look top down. Orient myself here. Now the first thing I'm going to use is I'm going to make the LED package, right? So the LED packages are just the individual DotStar LEDs, which is these guys here. And to get the dimensions for these guys, we have a technical data sheet here, which I already have open. Sure, I should click on that. It tells you how thick it is. It's 1.4 millimeters, just the package itself. And it's by 5 by 5 width and length. But the tallness, the height is 1.4 millimeters. So we got to know those numbers. So it's really straightforward. So I'm going to use a center rectangle. I'm using the sketch modeling toolbox to quickly grab my center rectangle. If you ever not used this, it's a little bit different than a regular rectangle. Where you initially click is where the center of that rectangle is. It has two construction lines already built in, so it has some built-in constraints and stuff. So I haven't appended this yet, so I'm gonna type in some numbers here. So 5 by 5 is what I want. I hit the tab to lock those in. They now have locked in. I'll click to place it, and there's our thing now. The cool thing is that we have these construction planes, which allow us to have this center point. So now I can move this point, and the entire square moves with it. And it's kind of hard to position it sometimes, but it's actually easier to make it relative to something else. So what I'm going to do is I'm going to have it in this area here, and I'm going to set it in place to another rectangle. This time I'm going to use a regular rectangle, and now we're going to draw the strip. So actually, you know what? Before we even draw the strip, we need to get our parameters in order. So I'm going to hit the parameters dialog here, and I'm going to hit the little green plus sign to make a new one. And let's start off with the pixel count, the amount of pixels. So I'm just going to go ahead and say pixel count. Now remember, the unit should be no units because we just need to be a number. This won't work otherwise, so I'm going to say no units. It's just a number. This is the number of pixels that we want. We're going to start with 8 just for easiness. That's the expression. It's just 8. I'm going to hit OK. Let's make another one. This time we do want it to be units. Millimeters is fine. I'm going to call this one the pitch. We can probably type that in, pixel pitch, and then they are 7 millimeters apart from each other, which is actually from the center, and that's what I didn't know. So the center to center is the actual pitch, not from edge to edge. So it's very important to note that. Because if you whip out your calipers and you actually measure it, you'll see it's actually 2 millimeters from edge to edge, not center to center. It's not descriptive in the thing here, in the product page, but it is if you kind of look at it, and that's kind of how most EagleCAD type stuff works. So that's the pixel pitch for this specific density of pixels. Remember, I'm using the high density pixels, which are 7 millimeters apart. So anyway, that's our number, and those are the ones we really need right now. So I'm going to use the regular rectangle, and I'm going to start from the center here of this origin, just so that it kind of locks it in place. So when I'm setting dimensions, it'll just kind of be a little bit easier. So now that I have this, I'm clicking it, and I'm ready to insert and type in my dimensions. So for the width is going to be 10 millimeters, because that's the width of the flexible PCB strip, not the LED, but the flexible PCB strip. And then the length, this is where we get to do our user parameter stuff. So we're going to say we want the pixel count, right? We want the pixel count, in this case it's 8. And then we want to multiply that by the pixel pitch. So when we enter that, that'll give us the dimension of 56 millimeters. Okay, 56 millimeters is how long the strip needs to be. All right, so now we got our strip, which is driven with user parameters. Our width isn't driven with user parameters. It could be if we wanted to, but it's going to be 10 for the most part. That's not going to change. What is going to change is the length. So now I need to position this guy in the right spot. So to do that, I need to figure out where the center, from here to here, what the center is. We can quickly do that with the construction line. So I'm going to hit the L key for my line tool. I'm going to roll over this edge here until I get that triangle. That tells me that's the midpoint. So I'm going to click on that midpoint. And then I'm going to go all the way back over here and then click it here at the end of the strip. And you see that triangle, so that means it is a midpoint. Now it's locked in. You see how it's turned from blue to black? Now it's locked in. I can't move it. But when this dynamically changes, when the width changes, this construction line will also change. So I'm going to make it a construction line by selecting it and clicking on the construction button, or you can hit X on your keyboard and that'll make it a dotted line. That lets me know it's a construction line. We use it as a reference point now for dimensions. So what I'm going to do is I'm going to drag this center line and I'm going to drop it on top of that, and that kind of locks it in place. You can still move it, but it's kind of guiding on that rail. So now what I'm going to do is I'm going to say I want that point to have a certain distance, hold down shift, to this edge. Then I'll hit the D key for dimensions. You see that's the distance because we're not sure where it is. So what we're going to do is we're going to put 3.5 millimeters. That's just the distance that I have come to realize with doing some measurements and stuff. That's the distance that it needs to be. So now that I have that, we have our dimensions set. Our stuff is locked. I can't move anything, and that's awesome. So we're pretty much done with this master sketch here. You can move these around if you want to kind of get a better look at them. And that's pretty much it for that. So I'm going to hit OK. Now what we need to do is we can start extruding our stuff. So I'm going to grab this and this, extrude that with the hotkey E, and I believe it's about 0.34 millimeters tall or thick. It's fairly thin, flexible PCB. So that's our strip. Now we need to extrude our actual LEDs. So I'm going to bring back the sketch. I'm going to select our profile that we did, hit E for extrude, and what I'm going to do is I'm going to start that extrusion from an object, from the top surface of our strip. So now when I grow this out, I don't have to compensate for it being below the strip. So now it's on top of the strip. So for the thickness, we read in the text sheet that it's 1.4 millimeters tall, and that's good. I hit enter pretty quickly, but just to look in there, I am joining it to the strip. You could, of course, use new body if you plan to do an explosion or something and you want the LEDs to be separate. It's up to you. I'm going to make a join, just kind of simplify it a little bit. And that's pretty much the first stage. So now what we need to do is to make, we need to duplicate this X amount of times. Fastest way to do it is with a pattern. So I'm going to use a pattern, the rectangular pattern. What do I want to pattern? Well, pattern type, I'm going to change it from faces. I'm going to make it features. That means I can now select a feature from the timeline. So I'm going to click on this extrusion. So I want to repeat that extrusion. Okay, the next thing I want to do is to select my direction. Where do you want this thing to go? Which direction? I want it to go on one of these edges, or you could use the origin here because it kind of automatically popped up. So I'm going to click on that. Then I get these arrows. So if I pull this arrow out, you can start seeing a ghosted view of what it's going to duplicate, where the pattern is. All right, and this is good. So for this number here, quantity, I want that to be the pixel count, right? That's the amount of pixels. All right, so there's 8 of them. And then the distances are pixel pitch. So I'm going to type in pixel pitch. And the distance looks like it's wrong, but we need to change the distance type to spacing because extent is the extent of it. I want it to be equal amount of spacing between them all. And I need to adjust the distance again to put pixel pitch. And now you can see it is pretty much where we want it to be. So I'm going to hit enter, and it will basically make that into a adjustable pattern. So the pattern is being driven with that user parameter, and our strip is being driven with some math saying pixel count multiplied by the pixel pitch, and it gives you that. So you have even amount of distance between these two surfaces. It should be 1 millimeter. And then if you go back over here, it's also 1 millimeter distance. Now, we said that distance between the pixels are 7 millimeters, but again, that's just center to center is 7 millimeters. The actual edge to edge is, I believe, 2 millimeters, yep. So that's why we got that, and that's why we have a little bit here. We have 1, not 2, because when you add 2 of them, we're going to split that right there. So hopefully that makes sense, and that is how to do the first step of it. The next step is to kind of add some details to it. If you had some resistors here, like NeoPixels, they do have resistors here on the side. You could add that. These are DotStar, so we don't need to add those. But what I could do is add the kind of circular cutouts here that kind of look like the LEDs, because that's actually how the LEDs look like. They have these little circles is where the elements are, the LED elements, and all the circuitry is actually in that little circle there. So that's what they look like. So let's go ahead and do that. Let me get the dimension. What is it? 2 radius. That's what, 4 diameter, 4mm diameter. So the way I did it is pretty similar. I actually just grabbed one of these guys, select the surface, and then project that surface into its own sketch with the letter P, it's the hotkey. And now I can use my circle tool, letter C, find the midpoint here and there. 4mm is what I want. Done with that sketch, then I click on that profile, and I'm going to do an extrusion. I'm actually going to cut inward by like 0.1 millimeters. Now I got that little bit of detail there. Now all I have to do is basically run a pattern, a rectangular pattern. Again, features is the pattern type. Click on that extrusion. Direction is going to go this way. Drag it out. We want the quantity to be the pixel count. We want the spacing to be the distance type, which is already good. Now for here, I need to have that negative value, but it's cool because we can put negative pixel pitch and that'll go in the correct direction, because if we don't have that negative, it'll just go out the wrong way. So make sure to put that negative in there, hit OK. Now we got this. Sweet. And we could keep adding things to it in that same manner. We can keep projecting sketches if we want to. And now I can adjust this. So I can say I want 32 of them. Let's say I want the whole meter, 144. I got a lot to compute. 144. Can Fusion do it? Yeah, of course it can, but oh my goodness, I actually haven't done this. This is how big the meter is, which is impressive. That is mighty impressive. So hopefully that's a nice introduction to how you can make your components parametrically driven, so that whenever you need to make something like this, where you really need to have that that component modeled for you, so that you can actually reference that component to determine the length of your part. In this case, it's a stick. It's a really useful thing. So again, I haven't had to model an LED strip in all of my projects. And this is kind of the first one where I really needed to do so. So I don't know. Let me guys know what you think. Is there anything that could improve this? Maybe there's some cool things I'm not showing you guys that you guys know about. Let me know in the comments. If you're new here, check out the comment section. There's a lot of great tips and stuff like that from a lot of people from the community. And again, if you want to check out this project, it is linked down below in the description. If you want to pick up some DotStar LEDs and stuff, make some cool projects, check out the links down below. Thank you guys so much for watching, and I'll see you in the next one.